We're heavily involved in producing materials and processes to support printed electronics development for sensors, flexible hybrid electronics devices, and other data acquisition systems. Hi, I'm Will Stone, and welcome to the Brewer Science Printed Electronics Division at the Jordan Valley Innovation Center here in Springfield, Missouri. All right, welcome to the Brewer Science Printed Electronics Print Lab in our Class 1000 clean room. Inside this lab is where we do all of our printing for printed electronics. We do have analysis tools to check in situ as far as print quality, imaging. We also have a facility inside of our lab to manufacture our own screens for screen printing. This allows us to turn jobs much quicker than ordering screens from outside, and also allows us to control the process of fabricating our screens to give an even higher print quality. So we're printing the first layer of a flexible hybrid electronics or FHE device. This will be one of about 6 layers when this entire system is printed. We're printing it on our 4-post Atmos screen printer behind us. This is an optically aligned system to where the operator, once we print the first layer, has targets to align subsequent layers to ensure accuracy of the print. Okay, this is our angstrom deposition tool. This system will deposit very thin layers of metals onto substrates, even finer than what we can do with our inkjet process. This machine will do both E-beam and sputtering in the same tool, which gives us some advantages of space savings in the lab, plus some different deposition techniques that we can't do with separate machines. So this is our Ceradrop F-Series inkjet printer. It's a 4-head system designed to print finer and thinner lines than what we can do with our screen printing process. Typically this will be used with anything that once we get below 100 microns in line width and such, we'll move over to this process versus screen print. It has 3 different curing systems in it, IR, UV, and photonic curing. So we can print multiple layers and cure without ever removing the substrate from the machine itself. Hey, this is our Keyence VHX fully digital and automated microscope system, enabling us to not only see a sensor, but actually go in deep enough after a change in magnification to see the print structure of the actual line that we just printed. We can also, what's called stitching an image, and it's actually taking a much larger area of the image versus what can just be seen as a single instance of the microscope itself. This is our DLP imaging laser. This is to laser our own screens in-house. Along with our screen coder and our developing facility, we can turn a screen in our facility in approximately 1 hour from CAD to print. So I'm setting up our laser here to just cut some devices out of acrylic. We use this for not only cutting hard materials, but also flexible materials such as Kapton and PET on our flexible devices. We do have an alignment system, an optical alignment system on this as well, so we can actually align to a print job and then get an exacting cut down to just a few hundreds of microns, typically on an outline of a device. So in this, we produce the design, the CAD work all in-house, transfer it over to the file format we need for the laser and cut. This is another one of those rapid prototyping things that we have the ability to do, to where we can go from idea to something in your hand literally within a few minutes, if not just a few hours. All right, we're in our circuit board population and fabrication facility. We can take either a traditional FR4 circuit board or a printed circuit board from our print lab and bring it in this facility and populate traditional electronic components, capacitors, resistors, ICs. We have our pick and place in this room. We have our full IR reflow ovens, stencil printers, and X-ray inspection equipment to ensure that the work we're doing meets all technical standards. So what this facility does, plus our print lab and other processing facilities, allows us to produce a prototype rapidly and get a device into our customers' hands for rapid evaluation. Instead of taking months, we can take typically a development cycle down to days with our in-house processes.
I'm Vijay Kayastha. I'm the lead device engineer at Brewer Science for the last 11 years. Mainly this lab is called the device lab. So this is mainly dedicated to test the different kind of printed devices. like temperature sensor. So for testing the temperature sensor, we have a couple of environmental chamber where you can precisely control your temperature and humidity. And also we have a lot of electrochemical stations here to test the different kind of water sensors.
So this sensor, we will use it to detect the light in the natural water or the drinking water. So that's our main application for this sensor.
And these are the we call flex sensor, and you can see the different sizes, the different form factors. Basically, they respond to bend. So if you are bending this one, basically this is a resistive type of sensor, and it will respond to that bend or strain on this one by changing the resistance of the device.
This lab is a materials lab. It's where we develop materials that go into inks, which will then print, and then they go into the devices, which you just saw in the device lab. The materials we make are generally based around nanomaterials, and particularly for sensors, nano makes sense because it has a very high surface area. On top of simply making the nanoparticles and functionalizing things to go into inks themselves, now you have to formulate it into something that will either go into an inkjet printer or some other type, screen printer, or some other type of coater. So even beyond this type of chemistry, we have chemistry that goes on over here where we will take inks that are working functionally, but maybe they're not printing quite right. And we need to adjust things like surface tension and viscosity in order to get these things to print.
Welcome to our electronics development lab. Once a circuit board is populated and assembled, it will come down to this lab for further hand assembling if necessary or testing purposes. We have your general test equipment like oscilloscopes, meters, plus other specific equipment to test the electrical characteristics of anything we have designed or developed. If you have any questions about the tour or anything you see in this video, feel free to contact us at info@brewerscience.com.